All right, welcome to this explainer. Today we are going to completely decode the architecture of Java array structures. Now, if you've been working with Java for a bit, you know that keeping track of information is absolutely everything. So today we're going to transform that abstract code syntax into a highly visual, logical system for managing your data. By the end of this, you'll be able to organize massive amounts of information with literally just a few keystrokes.
Picture this. You need to store 100 different product prices. Are you really going to write out price 1, price 2, all the way down to price 100? No way, right? That is a total programmer's nightmare. Imagine the absolute chaos of declaring hundreds of individual variables for one single application. Thankfully, Java offers a massive hero solution to this exact problem, completely streamlining how we handle bulk data.
So here's our roadmap for the explainer today. First, the power of arrays. Second, declaring and creating arrays. Third, initializing and inputting data. Fourth, passing arrays to methods. And fifth, multi-dimensional arrays. Let's get into it.
Section 1. The power of arrays, from chaos to order.
So what actually is an array? Well, think of it like a continuous row of physical storage boxes. You know, most applications require us to process multiple data items that share common characteristics. Instead of scattering those items all over the place, an array neatly packs a collection of variables of the exact same type under one single shared name. Whether you're dealing with integers, strings, or doubles, the underlying logic is always the same. One name, multiple values.
Look at this shift in syntax. It's a real game changer. A standard variable, like double price, can only hold one single value at a time. It's just one box. But by simply adding brackets, double prices suddenly allows us to store an entire list of values simultaneously. We're talking 3.30, 2.10, and 10.00, all bundled nicely together inside curly braces.
Moving right along to Section 2, declaring and creating arrays, building the structure.
Okay, so every single array in Java goes through this exact, strict, three-step life cycle before it can actually be utilized in your code. First up, you have to declare it, basically letting the program know, hey, this array exists. Second, you create it, which physically allocates the necessary memory space. And third, you initialize it, giving those empty spaces actual data to hold on to.
Now, as programmers, we absolutely love efficiency, don't we? To save some typing, you can actually smash the declaration and creation into one single combined statement. We define the data type with brackets, give it a name, and immediately use the new keyword to allocate its size. But, and this is a critical rule to remember, the size cannot be given before the array is officially created with that new keyword.
Now here is a fascinating and honestly critical quirk in Java, the zero-based index rule. When you create an array of 10 string elements, you might naturally assume they're numbered 1 through 10, but nope, Java starts counting at 0. So the very first element is always at position, or index 0. This means an array holding 10 elements actually ends at index 9. Grasping this little offset is absolutely vital for preventing those dreaded out-of-bounds errors later on.
All right, Section 3, initializing and inputting data, filling the boxes.
Now that our storage boxes are built and correctly indexed, how do we get data into them? Well, you've got options. You can use direct block initialization to declare a whole list of known values right out of the gate, wrapped in curly braces. If you only need to update specific spots, you can assign them individually by their exact index, like dropping the number 10 strictly into index 0. Or, for more dynamic applications, you can just fire up a for loop to actively read incoming user input data straight into your array, step by step. So, to put this all into perspective, when tracking the life of your data, you need to remember this strict relationship. When you declare an integer array of size 3, it allocates exactly 3 elements of memory. However, because of that zero-based counting rule we just talked about, the index sequence will always be exactly one number behind the total size. So it runs directly from 0 to 2. Make sense?
Which brings us to Section 4, passing arrays to methods, moving data efficiently.
This right here is where arrays absolutely shine when it comes to performance. Unlike standard primitive variables, where Java makes a complete copy of the value to pass around, arrays are passed by reference. When you hand an array over to a method, you aren't duplicating all the boxes. You're simply passing a map, a reference, to their memory location. This makes it incredibly efficient to manipulate massive data sets without bogging down your system memory.
And you know what? That streak goes both ways. A method can easily receive an array, process it, say maybe calculate a total score using a loop,
and then use the return statement to pass that entire modified structure right back to the main program. If you look closely, the method definition specifies int bracket bracket as its return type, cleanly closing the loop on our data sharing.
Finally, Section 5, Multidimensional Arrays, expanding to the grid.
Okay, so what happens when a single row of boxes just isn't going to cut it? We expand into a full grid. A multidimensional array is basically just an array of arrays. It uses two subscripts instead of one. The first defines the rows, and the second defines the columns. In a matrix like the one we're looking at, to find the number 4, we check row 1, column 1, which gives us the precise coordinate n sub 1 sub 1. Coding this structural grid in Java is surprisingly simple. You literally just add a second set of brackets. By typing int bracket bracket table and creating it with new int 2 and 3, we immediately construct an array that has exactly 2 rows and 3 columns. Just always remember that strict order, okay? Row size is defined first, followed immediately by the column size.
Now, to actually move through these grids, you're going to want to use a nested loop structure. It's kind of like a clock. The outer loop always controls the rows, and for every single row it looks at, the inner loop fires up and cycles through all the available columns in that row. It's an incredibly elegant and powerful way to easily read or print an entire multidimensional matrix straight to your console.
So you've mastered the straight lines and the 2D grids. You now have the foundational building blocks to manage some seriously complex data structures. But seeing how arrays stack opens up a pretty fascinating, mind-bending question. If 2 sets of brackets build a 2D grid, just how deep can this Java dimension rabbit hole really go? What kind of wild, real-world data would you even need to map out in 5 dimensions? I'm going to let you ponder that puzzle for your next coding project. Thanks for hanging out with me for this explainer. I'll catch you next time.